Okay, so chain rule. So this is a formula you get given in your formula booklet. Now, what it says is that y is equal to g of u. What that means is that you're going to have what I like to describe it as a function of a function. So, for example, you might have y equals 3x plus 4 to the power 5. Okay? So what you have here is you've got a function, and then that function has something happening to it. So in this case, this whole bracket is being raised to the power, excuse me, power 5. So it's not just x to the power 5, it's not just 3x plus 4, but it's a combination of those two things. Do you see what I'm talking about? It also might be that you've got something like y equals, no, it's just down. Forget that. Okay? So, this is the longer method to describe what's happening. So we know that we're trying to find the derivative. And what they do here is they split this up. So the best thing to do is to go through an example. So we're going to look at this question here. What we would do is we would say that this part here would be called u. So that's what I've said here. U is 2x cubed plus 3x squared. That means that y would now be known as u to the power 4. Okay, I'll let you just bring that in your heads. So I've said that this whole expression here is u, and therefore y can be written as u to the power 4. So now what we do is we've got two functions that we can differentiate. Now, if I were to differentiate this left-hand side, I wouldn't now say dy dx. What would I write? dy du. Nice. Because my rule, my expression here, has got u's in them. But the process of differentiation is exactly the same. So the rules of differentiation tell me power comes in front, take one off the power. So this would be what? 4u3. Trace the ends. This expression here, if I were to differentiate this would be du what? Dx. Yeah, because this expression has got x's in it. Okay, so this was dy du, and then this one is du dx. So we differentiate, rules apply. Power comes in front, take one off the power. So this one is
6x squared
plus 6x. Lovely jubbly. Okay? So what we're going to do now is put those two things here, this one and this one, into that formula that they gave us up the top here. So you'll notice this one says dy du, and on the right hand says it's du dx, and we're multiplying them. So secretly, if you like to think about it, what secretly happens is that this du part kind of cancels each other out, and we're just left with dy dx. Okay? So, what we would do now is say that dy dx is going to be 4u cubed multiplied by 6x squared plus 6x. Now, I need to keep this in a bracket because it's multiplied by all of it. And I now need to replace this u. Okay, so I go back to saying, well, u was represented by 2x cubed plus 3x squared. Thanks. Keep an eye on me. So whilst that answer is not a nice answer, the process itself was not too horrible.
That's the answer.
That's our final answer, yeah. Okay? So we...
So 2 to the power of 4. 2x cubed plus 3x squared to the power of 4.
Now remember, u was just what's in the bracket.
Okay.
The original question had been to the power of 4, yes, but remember we're writing what the derivative is.
Okay.
Yeah? So that would be how you would separate it. You'd identify your expression for u, you differentiate them, you'd put them back together. But let's have a little look at what we've actually got here. So what we've got is that original expression is here, yes? So the original was u to the power 4, sorry, that whole thing to the power 4. So our power came in front, and we took one off the power. So our power came in front, we took one off the power, and our expression stayed as it was in its bracket. But we then multiplied that by the derivative of what was inside that bracket. Yeah? And that's what's going to happen every single time. So it could well be that you, rather than say u equals, differentiate with in terms of u, and then have to replace u, you can just pretend or imagine that that's just a normal x, differentiate as normal but keep the bracket as it was, and then always multiply by the derivative of what's different.
Can you write this up?
Yeah, so this is what this next page is all about. So there's a faster method without rewriting the function. So, as I said, we had y equals 2x cubed plus, what was it?
3x.
3x squared to the power of 4. So to find the derivative, we would just say 4 bracket 2x cubed plus 3x squared to the power of 3 multiplied by, whoopsie, 6x squared plus 6x. So this was differentiate, pretending the bracket just x, and then multiply by the derivative of what is in the bracket.